We are the Purdue MS BAME team, and our client manages a large beverage equipment fleet that generates more than 332,000 service records across 4 separate data sources, logged under 86 different trouble codes. The result was a 57.5% gap between what this call center dispatches and what the engineer actually finds. There was no unified view of the fleet performance, and that's where we came in.
We started with data harmonization, appending 4 source files into one 322,000-row master file which retained 100% of the records. Then we used NLP, TF-IDF, and K-means with a fixed seed to collapse 86 raw codes into 10 clean defect families. Just 4 of those families now explain 82% of all service activity. This master dataset powered every analysis that followed.
Phase 1 and 2 set the baseline, 4.07 calls per unit, almost $200 per work order, and a 36% reliability gap between refurbished and new equipment. Phase 3 then benchmarked 4 vendors on identical metrics. Vendor A dispatched 4.57 calls per unit at least $85 each, far above the peers. Vendor C was the best, with the lowest repeat rate and the longest recurrence gap.
Phase 4 isolated the refurbishment process, a 29% reliability gap that is process-driven, not wear-driven. We then trained 3 gradient-boosted classifiers to predict failures within 28, 56, and 84-day windows, scoring 15,325 assets. The output is the top 10%, 1,533 immediate action assets, flagged for proactive service before they fail. Everything lives in a 5-phase Power BI dashboard the client team already uses. Our recommendations: review vendor A immediately, prioritize the 1533 flagged assets, audit the refurbishment process, and embed the pipeline into the 28-day planning cycle. Projected impact: a 20% service cost reduction, a 15% drop in repeat calls, and over 1,000 man-hours saved every year. Thank you.